Syntropics involves a diverse range of plant species which complement each other in terms of growth, root structure and nutrients. Nothing in a syntropic system goes to waste. Everything from branches, leaves and other organic material is recycled and put back onto the gardens. With the continual addition of organic material in a syntropic system, there's no need for fertilisers and pesticides. The real benefits of syntropics is that it's a naturally evolving ecosystem, so it's creating soil, stores water, there's no soil erosion, there's more fertility in the system. So much like a natural forest, the syntropic method evolves naturally, and as trees die, grow and evolve, they add and subtract to the system, making it more dynamic. Here where we are in northern New South Wales, we can get 35 to high 30s days in summer. And then, then we can have a cold front come through and it can be like 22 or 20 the next day. So if you're just planting normal crops, like a normal traditional vegetables, and you get those hot days, they'll get fried basically. So if you've got overstory canopy with some of these natives, as we're seeing around here, they get protection. And I'll show you some examples soon that some of that are exposed to the open, they really have got fried. I just wanted to trial some stuff. We've got some coffee seedlings out here in the open, and they've got nailed, and where understory coffee, they're thriving. So it's really obvious that the filtered light and the natural less harsh light can really help get a functional system happening, just like a forest. Let's have a look now at that coffee I was talking about. So we can see here we have this coffee that's looking a bit sad. So I have got this big tree here which actually protects it in the summer, but it's deciduous, so it's lost its leaves. So that coffee's a little bit exposed now, so it's not looking so good, as well as this one is also looking a bit sick. So because it's exposed to that hotter westerly sun in the afternoon at the moment. Whereas this one here, we can see it's under this pigeon pea. There's a couple of pigeon pea protecting it, so it looks a lot healthier. So it's much more vibrant and green and hasn't got that yellowy tinge to it. So that means it's happier. So that's a good example of we can see that the syntropics and the overstory canopy helping protect that and shelter that little seedling as it gets going. So if you walk into a forest, sometimes I walk into a rainforest and it's like instantly, it's 10 degrees cool, and then you step outside where it's all been cleared and it's just blazing hot. So the forest actually acts as a thermostat and it keeps temperatures more regulated. That's what a syntropic system's trying to do. It's trying to evolve and create its own ecosystem, therefore it's more balanced and maintained, versus it's got these highs and lows of extremes in temperature. If you think about a forest system, it's much more moderate, whereas a normal agricultural system is quite exposed. If you've just got monoculture, corn, oats, whatever it is, then it doesn't have that resiliency. So if they get a drought or hot days, then those crops can be destroyed. Whereas in a syntropic system, it's more managed. You don't have those volatilities, which really makes a huge difference. And I'm seeing that now just from the early days in the last year or so that I've been doing this. So it's really interesting to watch firsthand how that evolves, and it's interesting to watch that in real time. It's so obvious when you've got a plant that's out in exposed sunlight versus a plant that's undercover and understory, and it's getting that filtered light, not so harsh conditions, and they're just thriving. Here's another really good example here of, we've got these pigeon pea and this banana here providing some filtered light from that westerly sun, and there's better soil, the water retention here. You can see it's rich soil, and yeah, it's not evaporating as much, so we have to hardly ever water these beds here at all. And you can just see that's what this syntropics, this overstory canopy provides, that shade and that shelter from the harsh conditions. Really does make a big difference. There are always plants evolving and emerging in a natural forest system. So you see seedlings on the ground and they're protected by the larger trees initially, and then they get their root structure in place and they build and they grow into a mid-level and then a canopy tree over time. And that's kind of what Syntropics is. We're trying to replicate a natural forest system, and that's called stratification or strata. So it's basically layers, different layers. We got low, mid and high level strata, and that's simplistically looking at. We'll get into more detail later into the stratification side of things with the Syntropics. All plants have different size, growth, habits and biological traits. So we're using those traits to develop a Syntropic system. So we've got some lower level shrub-like plants that might be 2 or 3 meters tall, and then we have a mid-size strata plant that may be 10 meters tall, and then we've got an overstory canopy or emergent layer which may be 20, 30, 40 meters tall. So we're using those habits and requirements and growth rates of each plant to mesh into a system to make a Syntropic system much like the natural forest system we see. The idea behind this is to create a harmonious ecosystem where plants work together and complement each other. The end result is we have a sustainable, resilient and highly productive agricultural system. To summarise, there's roughly 5 components to a Syntropic system. The first being there are diverse plant species which complement each other. The second being plants are arranged in layers or strata where the taller trees provide support and shade for the smaller seedlings and shrubs that are coming up through the system. The third being organic matter recycling, where 100% of the material on site is put back into the system. The fourth being biomass management, where there's no external inputs added to the system. So all the material comes from on site and it's added back to create mulch, which ultimately goes to make soil. The fifth being crop rotation, where we're constantly adding new species and crops to the system. This is a very brief overview of Syntropics. We'll get into more detail in later videos, but for now, thanks for watching and please share and subscribe to our channel.